Hello, everybody, and welcome to PASCO Laboratories. So nice to have you with us. I'm JP, and a lot of people ask what the P stands for. Well, I'll be honest with you. The P stands for physiology. That's right. I was named after a branch of science that studies the parts of living organisms. And if you're thinking parts, which parts? Well, this week we're thinking hearts. And why are we thinking hearts? Well, because it's Valentine's Day. That's right. For those of us who are celebrating, it's Valentine's Day. And for those of us who are in South and Central America and joining us, happy Dia de San Valentine. And for those of you who are in outer space and speak Klingon, happy Gamusha. Gamusha. That's Klingon for Valentine's Day. That's right, we're having a little bit of fun with the heart today because the heart's a very important organ. Of course, I'm sure you realize that. But did you realize that your heart beats 115,000 times a day? It does. That's a tremendous amount. And while it's doing all that beating, it's pumping over 2,000 gallons of blood every single day. And for those of you in the metric system, that's nearly 7,571 liters of blood. Well, you can see how important the heart is and how busy it is, but don't just take my word for it. We want to take a look at an expert who's doing some experiments with the heart, and we're going to go home to explore the heart with Barbara. Barbara.
Hi, folks, and happy International Girls and Women in STEM Day. Thanks for everything you do out there. So we're going to answer the question, how does exercise affect heart rate using the wireless hand grip heart rate sensor? So I'm going to show you on my screen. I have SparkView. And this sensor is a little bit different in the way it connects. We don't have to turn it on. You just have to hold on to it to get it to turn on. So I'm going to click Sensor Data and have my software look for it. And there it is. It just shows up without me having to turn it on. And I can connect it just by clicking. Now, normally to check the effect of exercise on my heart rate, I'd have to sit here and jog for 3 minutes. So rather than you watching me jog for 3 minutes and me breathing excessively into the mic, I recorded myself doing this activity this morning, and I have the SparkView file to show you. So let me switch to that. So here's my recording, and I'll narrate what happened as the data shows up on the screen. So here goes. I'm going to hit play. So first I start just by sitting and still to get my background resting heart rate so that I can make a comparison and know when I've recovered after exercise. And then short, you'll see the heart rate changes when I begin exercising. So I'm still sitting, getting a background, and now you can see it jumps up because I start running in place. And I'm going to keep running in place. And if I'm doing the lab activity that's associated with this, which I'll show you in 1 second, I'm going to keep running in place for 3 minutes at a pace where I won't pass out. So if you're doing this with students, you want to make sure your student groups pick someone who feels fit and good, where they can do 3 minutes of vigorous exercise without passing out. So I'm still running here. You can see my blood pressure, or my heart rate rather, is increasing. But I don't go the full 3 minutes. You'll see soon that the data will start to drop off and slow down because I'll stop exercising at some point. And I know I went just near 130. So while that's getting up to the maximum, I'm going to bring up a second window on the screen there, and it's going to block your digit view of the heart rate. But you can see on the graph that it's already looks like I've reached the point where I stopped exercising, and now I'm going into recovery where my heart rate's returning back to normal, to the resting rate. And that might take a long time depending on how healthy I am. So while that video is going, it's going to, I stopped recording the video before I reached recovery, just for time's sake. But let me show you that lab I was talking about. So this is the experiment library. The lab is called Exercise and Heart Rate, and it's in the Essential Biology Teacher Lab Manual. But if you log in with your teacher account, you can see the teacher files that go along with it. So let me show you that lab exercise. So it begins with part 1. You can see the picture of the student holding the paddles. Part 1 is just getting that resting heart rate. And the table, I know it's tiny, but in the table you can see there's a lot of data collection opportunities here for students to not only collect their own resting heart rate, but also do 3 trials and get an average. So we're teaching we're teaching scientific study skills and collecting data and getting more than one trial so that we can average in case there's some anomaly in one of the trials. Also, collecting multiple students' data so that you can make a comparison and then later on talk about variation within a population. So then in part 2 of the experiment, that's where the exercise part starts. So the students run in place for 3 minutes and they find their recovery time, where they just subtract out the time when they stopped exercising all the way to however long it took for them to recover back to their initial heart rate. And so you can see in my video there, this is about where I stopped, where it goes flat. Okay, and in the questions on this lab experiment, it asks students questions related to variation in population, relating the respiratory system to the circulatory system. They work together to keep your body at homeostasis, where it's if you're moving more, we have to increase metabolism. How are we going to do that? So connecting multiple body systems here and making connections between multiple concepts in physiology. Now, something else interesting I did with this activity, I'm going to open an experiment that I've saved earlier. And I've set this up to run some code. I'm going to go to the next page. So you can see this is the file I had earlier this morning. And on the left side, I have a heart rate. On the right side, you're going to see some interesting information pop up based on whatever my heart rate is, resting heart rate. I'm going to click Start. And at 70 beats per minute, it says that I am mild with an orange heart. What could this be? Well, since it's Valentine's Day, this must be a love tester. Oh, look, I'm passionate now because my heart rate just went up. So exercise must be good for me, right? It's going to make me higher up on this love tester. So what would it take for me to get to that top level? And what is the top level? Let's take a look at the code here. I'm going to hit stop. And let's look at the code. So I've got some Blockly code here, and I did a fun activity with it, but we can talk about how this can also apply to the concepts that you're trying to teach in physiology. So my code is saying, it's in a loop, and it's saying, look at the value of the heart rate sensor, and if that value is equal to or greater than 90, then your value is you're smoking hot. You are high up on that love tester scale. And these are just arbitrary numbers that I came up with based on the fact that I know that my heart rate's somewhere in the 60s. These are each threshold amounts where the, my sensor just turned off. That's why I got that pop-up. So each of these threshold values will give a different message. So that's the fun way to do this, but the way students could use this is they could take that class data, the population data, where they made comparisons between other students and their resting heart rates and recovery times, and apply that information here to give some message about possibly where a student is in the range compared to their student group. Or maybe it's a motivational tool, like you're exercising, you're using the heart rate sensor, and you know what your target heart rate that you would like to get to is. You can make a motivational message when you're approaching, like go a little faster, or you got it, you're right there, just stay there. Or if you're going too hard at it, your heart rate's too high, then there's a danger message. So this is a fun way to apply not only content knowledge, but also computational thinking. So I'm going to pass it back to JP to give some more examples of that.
Thank you, Barbara. And of course, we all did that test around the office, and I guess you probably already guessed that I am smoking hot, right? You guessed it. That's right. So thank you for that, Barbara. That was a great way of integrating in computational thinking, and happy Kamusha to you as well. And you might be wondering out there, what's the animal with the smallest heart? Well, did you know that it was the fairy fly? And if you were wondering what the animal is of the largest heart, well, it's the whale. And if you were curious what animal has absolutely no heart, well, just ask the people that work here, because they say it's me. Whether that's true or not, another important aspect of your heart is the fact that it must maintain a pressure. And a great way to check your pressure is with this wonderful device that I put on, which is called the sphygmomanometer. That's right, the sphygmomanometer. The sphygmomanometer actually measures the pressure in my artery at the point at which it's the highest and the lowest pressure, the pressure at which my heart is contracting, or the systolic, and the pressure in between the beats, which is the diastolic. Now, take a look at my screen. I've already set up a program here that is helping me measure the systolic and the diastolic pressure. And we're going to do this live, and hopefully my talking through this isn't going to screw it up too much, but watch me pump up my device here, and let's let the pressure go down. On your screen, you should actually be seeing my heartbeats, and those beats are exactly what it's measuring, the point at which the cuff pressure is the same as my high pressure, and the cuff pressure is the same as my low pressure. Let me see what comes up here as we expand this out and look at those numbers. Give this a second to come down and find out that according to my measurements, what's it going to give me? I might have talked through it and it may not have given me a very good number. Might not have given me any number at all. Well, I guess that answers the question about if I have a heart or not. My talking has screwed up that measurement. We're going to try it again, but before I try it again, and I'm going to be a little bit more quiet, I want to show you what I did with this. I actually designed a program that is very similar to what you might find if you go into a drugstore and you sit down at one of those machines, and it's going to tell you high pressure, low pressure, warning. Take a look at what I did with a little bit of research, the kind of research your students would do. I determined that anything above 120 for me is high pressure. And so I wrote a program to say anything above 120 is a stressed danger point. Anything below 120 is, of course, a good blood pressure. And in this case, if it's 0, it's just measuring. So this is what the screen looks like then. I'm going to go to the screen that I designed that tells me those things. See, it has my high blood pressure. It tells me testing in progress. We're going to try it again. And hopefully I'm going to pump up my sphygmomanometer and I'm going to let that pressure come down. Again, watch the screen. Watch how wonderful it is that we're looking at this data. Try and be a little bit more quiet here as it's measuring. Let me spread that out so you can actually see my heart beating here. Look at that. And did it capture it? Once again, I was talking through it. Tell you what I am going to do. I'm going to do one of these in silence, but I'm going to do that while Barbara's talking, because blood pressure isn't the only thing that's important about the heart. It's also about temperature. Did you know you can actually stop your heart if it gets too cold? Sure. Sometimes between temperatures of 68 and 77 degrees Fahrenheit, your heart will stop beating. Of course, we call that hypothermia. If they actually induce that, they call that deep hypothermic circulatory arrest, or DHCA. That's when they cool your heart to the temperature that it stops beating. Well, I don't think Barbara's at the temperature that her heart stops beating, but she is going to do something fun with temperature that's related to what she did when it came to heart rate. Let's take a look at what Barbara's doing with temperature. Barbara?
Thanks, JP. Thanks, JP. The first thing I wanted to show before I go back to that activity similar to the one you saw previously is I want to talk briefly about the fast response temperature sensor. So you might have seen the stainless steel probe, temperature probe, but for living things, sometimes it's important to get the changes that happen really quickly are sometimes harder to pick up on the stainless steel temperature sensor because the sensing element is surrounded by a stainless steel cage. So this temperature sensor has this little sensing element right here with a thin layer of plastic over it, and that means it's easier to pick up those small changes that otherwise might go unnoticed with other sensors. So that's why this is the sensor that you find oftentimes in the biology experiments if you go in the experiments library or if you look at the Essential Biology Lab Manual. So I'm going to talk briefly about an experiment that Heidi and I did together, and this is available on the PASCO experiment library. I'm logged into my teacher account, so I can see that there's a video and a data set that goes along with this. So this is something you can do with students. I'm gonna scoot into the 4th minute here. So, well, I guess I can pause here and show you the setup here. So Heidi is the victim here. She is the person that's going to fall in the ice water. Well, actually, just her hand is going to fall into the ice water because we don't want to stop her heart. So what we're going to do is we're going to put one of these fast response temperature sensors on one hand on one side of her body, and a second sensor on the other side. And one hand goes in ice water, the other hand stays at room temperature. And we look to see, how does the body maintain homeostasis when part of the body is exposed to an extreme stress, like being in ice water, major temperature change that could be deadly. So that's the setup you see here. And I'm going to scoot up and speed through to where you can see that's where we're setting up the sensors on her hand. And this is where she's, we're getting the background data. What is the normal temperature on each side? And then we're going to expose her to the stress of too cold of a temperature and see what happens. Then after we do that stress, we're going to try a different stress where we cool down her hand a different way. Let me scoot to 4 minutes here. Where we're going to expose one of her hands to a fan and see how different that might be from the stress response when there's a bigger temperature change, like going into ice water. So that's one use of the fast response temperature sensor. Another thing you can do with it is you can go back and write another program that uses temperature with some warning scales. So I'm going to go back into my Spark lab, and now I'm going to connect the temperature sensor. Once I've got a file open, I can do that by hitting the Bluetooth menu and connect the temperature sensor. Okay, and I'm done. And now I'm going to modify the code. Now that I have the sensor connected, I can just pick it from the drop-down menu in my code. So the sensor is now the temperature sensor. And I might change the output, or let's just keep using the lab tester code, because I did go around the office at PASCO and I got some sample data to see what is the front side temperature among PASCO employees. And it turns out that the person with the highest temperature, that would be Debbie. Debbie is the smoking hottest person at PASCO because she had the highest temperature. So I'm going to spike it here and make myself smoking hot by saying, if the sensor value is greater or equal to 20 degrees Celsius, then you're smoking hot. And I'm going to test that code and see if it, and I have to change my display from heart rate to temperature. That's all I had to do to get this to work with a different sensor. Yeah, look at me, I'm smoking hot. But of course, to be fair, I should have used the temperature ranges that I've found amongst all of the people at PASCO who are in my same, the adult temperature range group. That would be fair. Okay, with that, I'm going to pass it along to JP.
Thank you, Barbara. Another great demonstration and a nice way to connect computational thinking. And while Barbara was doing that, I went back and I got my blood pressure. And probably nothing makes your blood pressure higher than trying to do a live program and get live data. And we can see that from my results. Take a look at the screen here. I actually captured it, had to sit quietly. The great thing that we're looking at here isn't just the fact that it got my blood pressure, but what a great teaching tool. I can actually see my heart beating, that actual pressure, that systolic pressure when it's pushing up against the cuff, that diastolic pressure when it's at the lower end of the cuff. You can see that. Now I'm able to talk to my students about what blood pressure is and how this device actually measures blood pressure. But then I took that through my program. Remember, my program was designed to tell me if any point is less than 120, it's great blood pressure. Anything above 120 would be a danger, stress. And so when we take a look at my output screen for when it was running this, it is going to say 146, which is a kind of high pressure for me, most certainly, and it says stressed danger. So I wrote the program, it's modeling it, it models a program, the type of program that would be used if you were sitting in your pharmacy and doing this exact same thing, but the machine we're running, we did it here, and we're actually able to study that. So you can find great activities like this lab on blood pressure right in our own library. Just go on to PASCO.com, take a look in our library, type in blood pressure, you're going to find this activity. And if you're studying physiology, it's not just pressure and it's not just heart rate. We have an entire physiology package that's heart rate, EKG, spirometer, and it's also going to measure the pressure and heart rate that you saw right here. And if you just want to do some basics in biology and you want that great little temperature sensor that Barbara was talking about, no problem. We've got the biology bundle package right here that's got the labs written and an example of how to do computational thinking with all the great devices you see here that are measuring pH, carbon dioxide, pressure, temperature, and of course conductivity. All the things that you need for basics of biology and all the things that you need to study physiology right here at PASCO. And of course, we're so thrilled that you joined us here on this wonderful day. Thank you for being my Valentine. Thank you for everybody for joining us right here on Valentine's Day. And I want to wish everybody, of course, the best of luck, great teaching, and good day.